In this video, I'll be covering the remainder of the problems 9 through 13 on the test review. 9 says evaluate the following functions at the given value by division. Explain what the solution tells you about the polynomial. I can go ahead and share with you that even though I say by division, you are welcome to do division, but I am okay with you just storing the value and finding the answer. So for number 9, if you're told that x equals 1, take 1 and store it as x. By the way, it also says to explain what the solution tells you about the polynomial, and be sure to write the explanation as you were taught in class, and that's as it relates to the factor theorem. So if we store 1 as x and then evaluate the function by typing in x to the third minus 3x squared plus 5x minus 3, always look back to make sure you typed it in correctly, we get 0. So that means that f of 1 equals 0. Based on the factor theorem, recall that if, when you evaluate, you get 0, it means you should be able to write the factor. So think of it this way. If x is c, then the factor is x minus c. So what we can say is that because it equals 0, we know that x minus c is a factor. So recall that there's two ways that I taught you to write that. You can either say that x minus 1 is a factor because f of 1 equals 0, or you can say f of 1 equals 0, therefore x minus 1 is a factor. My preference is to do the latter. So f of 1 is equal to 0, therefore x minus 1 is a factor. The other one would be x minus 1 is a factor. I'm just going to write it up here in case you like to do it that way. Is a factor because, so use the inverted dots, because f of 1 equals 0. Okay? Next, here I tell you that f, to evaluate it at f of negative 3, so negative 3, store as x enter, 2x to the third plus 4x squared minus 5, hit enter, and we get negative 23 this time. So write f of negative 3 equals negative 23. So remember that based on our factor theorem, if it does not equal 0, then then x plus 3 would not be a factor. So if given the x value, the factor would be x plus 3. So you should be prepared also if I tell you to divide tomorrow and I give you the divisor as x plus 3, you need to evaluate f of negative 3. But we could say here that f of negative 3 does not equal 0. Therefore, x plus 3 is not a factor. All right. Number 11 asks you to describe the relationship between the zeros and factors. I do want you to write a sentence explaining what it means and to give an example. So please, when you write sentences in math and on your test, always write in complete sentences. So to describe the relationship between zeros and factors, we could say that if a polynomial p of x has a 0 at c, then the quantity x minus c is a factor. If p of x has a 0 at c, then x minus c is a factor. But that goes both ways. Remember from the notes, we could say if for p of x, if x minus c is a factor, then c is a 0. So you're going to need both statements. Memorize it. For example, If x plus 3 is a factor, then negative 3 is a 0. We have talked about that until we were blue in the face, so I hope you get that correlation there. Number 12 says, describe the remainder theorem and how it relates to long division. So remember, you're going to need to use the definition as you have in your notes for remainder theorem, okay? The remainder theorem says that for p of x divided by x minus c, f of c equals the remainder. For p of x divided by x minus c, f of c will give us the remainder. How does that relate to long division? We would say that, let's see, when using long division, and I want you to relate it to what I did up here in the division problems to check our answer. When using long division, the remainder is the same as f of c when dividing by x minus c. And go ahead and throw in an example. Well, you don't need an example. For p of x divided by x minus c, f of c is equal to the remainder. So when using long division, the remainder is the same as f of c when dividing by x minus c. Next, describe the factor theorem and how it relates to zeros and give an example. The factor theorem says for p of x divided by x minus c, if f of c equals 0, then x minus c is a factor. For p of x divided by x minus c, if f of c equals 0, then x minus c is a factor. So, for example, if dividing by x plus 2 and f of negative 2 equals 0, we know that x plus 2 is a factor of your polynomial p of x. For p of x divided by x minus c, if f of c equals 0, x minus c is a factor. So in other words, if we divide by x plus 2, but then we evaluate f of 2 and we get 0, then we know that x plus 2 is a factor of the polynomial p of x. Okay? And I ask you to state an example. Say we have p of x. I'm not going to make you do a long drawn out one. If p of x is divided by x plus 5 and f of negative 5 equals 0, then we know that x plus 5 is a factor of p of x. And finally, that concludes your test review.